All right, welcome everybody. Thanks for attending our session. This is warehouse automation and optimization, which we'll talk about with AWS and Amazon Solutions and Technology. My name is Eldon Travers. I'm a principal consultant with PRO205 Expert Services in our supply chain team. I got a couple amazing colleagues with me today.
Hi, I'm Unnati Joshi. I'm a senior program manager with Global Engineering Services within Amazon.com, and I will be talking to you about some technical aspects of some of the things that we are offering and some of the deliveries we are going to have for the customer.
Welcome and good day. My name is Corey Gines. I'm an AWS Cloud Delivery Architect, and I'm in our Manufacturing and Industries Professional Services team. I've been with AWS 5 years, and I'll be speaking to you today about the last 3 phases of delivery of design and simulation, which are all the delivery phases.
Perfect. Thanks, Unnati and Corey. So you all know Corey and Unnati a little bit. I'll be referring to them a number of times throughout the session. So if I say, Corey will introduce this or Unnati that, you know who I'm talking about. Just to circle back, so again, Eldon Travers. I have spent my entire career in and around warehousing. This is a little bit of an unorthodox session for reInvent, but the ability to blend kind of what we do in the IT and tech space with our supply chain solutions is a pretty passionate topic for me. So really excited to be able to get a chance to talk to you. As mentioned, I spent 20 years driving forklifts in college, all the way up through implementing cutting edge computer vision solutions and machine learning and warehousing today. So it's been quite a journey, and getting a chance to join Amazon and AWS and see how we do that is something that's a pretty fun topic for me. So just to make sure that you're all up to speed, can I, really quick show of hands, has anybody been to an Amazon fulfillment center? Just a handful of you? Okay, very good. So for those that have not had a chance to be or ever take a tour of an Amazon FC, we're going to catch you up in 1 minute. So,
have you ever wondered how humans and robots work together at Amazon? From the moment a product enters our fulfillment center until it heads out to a customer, Amazon technology helps our associates in so many incredible ways.
Amazon introduced our drive unit robots in 2012, which led to 300,000 new full-time jobs.
These are the stow stations. They use artificial intelligence and computer vision.
Yeah, pretty cool.
This is the palletizer. It uses computer vision to stack totes of products.
There's so much cool technology that goes into this.
Oh yeah? Like what?
Well, like 2D imaging, a laser sensor, high motion performance, and 165 kilogram load capacity.
Wow, amazing.
Our tech vests help communicate with the robots to keep us safe while working on the field.
I think your tech vest could use a little more tech.
Thanks, but I think my vest already has everything it needs.
Incredible!
I know, right?
With Amazon's human and robotic powers combined, we are building the future of technology together.
all right, thank you. So you're all Amazon Fulfillment Center experts now. But seriously, if you haven't had a chance to go, you can if you've got an AWS account manager, if you're in contact with somebody from AWS, they can get you into an Amazon FC. So we've got a fulfillment center tour program, pretty awesome. Also get a chance to get our teams to come out and visit our customers' fulfillment centers as well. We have got a learning from Amazon work stream that we call it, and there's a lot of information exchange and learning. So pretty cool topic. If there's some interest, let us know. One of the things that comes out of our fulfillment center tours, almost every time we do them, universally are requests for, how can maybe my company take advantage of some of the solutions that we've seen today. So as you see, some of the topics up on the screen, but machine learning and AI, obviously, computer vision, digital twins. We have a lot of robotics and automation in our facilities, and so the rationalization or business case about how and when to invest in different types of automation. These are topics that are really near and dear to many of the customers and folks that we talk to. So out of that, we've created essentially a program or a portfolio within our AWS professional services team. And we call this warehouse automation and optimization. That is a mouthful, so you may hear me refer to this as WAO for short. And really what WAO is a defined way to take a customer's supply chain or warehousing and fulfillment operations facilities on this transformation journey. If anybody's ever been in a warehouse, the stereotype is this dingy, dark, long building with dust everywhere and pallets stacked up to the ceiling. And taking a lot of customers have a really hard time, visualizing how am I going to get my building from this state to something that we see like in an Amazon fulfillment center. And really this program is built for that purpose. And we do this through these 4 modules that you see on the screen, with the assessment module, design and simulation, which we'll talk about a lot today, systems and data synchronization, and intelligence. We'll get into the details here in a little bit. One of the things that I wanted to call out is the delivery of this program is unique in that we bring some really strong resources both from AWS. So I think you're probably all aware, but everything that we do in our Amazon fulfillment centers runs on AWS, obviously. And then we also bring resources from Amazon.com. Think about from an industrial engineering perspective. And other skill sets. And we also bring in some strong partners. So many of you are likely partners. There's a lot of amazing partners here, a lot of ISVs, a lot of robotics and automation providers, and we bring this team together to form a really powerful synergy. So I mentioned a moment that transformation journey and that ability to form a path for a customer to get from this really legacy, antiquated, dingy warehouse to something that looks like what you saw in the video tour. And the way that we do that is really through this 5-step approach. So the assessment I'll talk about here in detail, but it's the identification of viable use cases and the building of a business justification behind those. Prioritizing those use cases and building them into a roadmap that's approachable. Moving in generally to design and simulation next. We talk a lot about MLAI and computer vision and document digitization, but if the building isn't the right size, all that stuff goes out the window. So helping a customer understand, are my facilities in the right geographical locations? Are they the right size? Do they have the right layout? And really testing this through 3D modeling and simulation, we'll get into all that shortly, is really what we achieve here. We move next generally into the system synchronization piece. And this is where we take a look at the applications landscape. Bringing in, I mentioned partner ISVs, whether that's an ERP provider, a warehouse management systems provider, labor management systems, and others. Once that application landscape is in place and right-sized, we get into the data strategy. And the connected data strategy on AWS, I'm sure you can see or have seen probably many presentations on data already. That's a competency for us. But getting these disparate data sources connected and harmonized on AWS really enables the final phase in the journey, which is that WAO intelligence module. And that's where the MLAI, that's where the computer vision and the document digitization and those advanced digital twins come in. So it's a phased approach to take those customers again from that legacy state to something that you see in Amazon. So the landscape that you see on the screen, I'm not going to go through this in detail now, but Corey and Unnati and I will kind of progress through this and show you what these technologies look like or some examples. But what I want to do on this screen instead of dive in is just kind of tell you what the program is and what it isn't. So what it is modular. Think about it like a menu. Many of our customers want to take advantage of just a computer vision solution. Or just a document digitization solution. And so we jump into that and it works really well. But others want to progress through the entire thing. So there are 15 to 20 different technical architectures that sit underneath the map that you see. Various flavors, computer vision. I'll just take computer vision as an example. So we've got architectures and productized computer vision for moving asset tracking, computer vision for inventory control, computer vision for personal protective equipment detection, safety and security. Is there a forklift still loading the truck? So make sure the driver doesn't pull away from the dock and dump the forklift out into the yard. So those are the types of use cases, and these are all come with distinct architectures. So what it is not is not let's say defined by the customer's existing application landscape. We're agnostic to our program. It doesn't matter if you run SAP on-prem, if you're running a WMS on a competitor's cloud. Ultimately, we work with customers to bring our solutions generally leveraging the use of that connected data strategy I talked about. But you'll never hear us talk to a customer or say, hey, you need to migrate your ERP to AWS or we won't work with you. So a few guardrails there. I want to talk quickly about the assessment process. And what I'd like to do is introduce Patricia. So we have a fictitious customer with us today, but one that represents a number of kind of real world customer journeys that we take our customers on. And so Patricia in the picture here, let's say that she's a director of supply chain for an automotive manufacturing company. And she's got a number of warehouses spread out throughout the country, maybe throughout the world, where they're housing finished goods, OEM, aftermarket, spare parts for automotive. And so Patricia's interested in taking this very distributed network of supply chain facilities, ones maybe that were acquired through M&A, that are running on different applications, and really kind of standardizing those and modernizing them up to a point where it makes sense, something along the lines, on this Amazon-like journey. So throughout the course of the presentation, Corey and Patricia and I'll check back in on Patricia's journey, but most of our customers, we recommend start with the WAO assessment. So what is that? It's generally a 4-week process where we send our teams, and this would be supply chain experts from Amazon, from AWS, out to our customer site to put boots on the floor, to walk the facility, look at processes, map out material flows, understand what data flows look like, what integrations look like between different systems. What is the data strategy? Is there a data strategy? And we really document all this stuff into a set of use cases. Generally, by the end of a week on site, we'll have created a bespoke listing of use cases for that customer or identified. Oftentimes, the customer has a number of use cases they already complain about. For example, hey, we know we're unable to find sufficient labor to staff this very manual area of the warehouse. And so we'll talk about that, but it's never happened where we didn't walk out identifying a whole bunch of use cases that customer or that supply chain company didn't even expect to talk about. I like this example set. This is a sanitized from a real world customer assessment. I like this because it shows the breadth of the type of solutions that we can bring from AWS and Amazon. Everything from predictive maintenance solutions, all design and simulation, the use of ML and AI for quality, document digitization. It covers the scope of our portfolio very well. Once we have that list, we'll generally provide a very Amazon-like consulting project. For those that aren't familiar with the way that we do things, you probably have heard things like the working backward process, PRFAQs. We employ all that, and we are writing up how would we solve this at Amazon document? What does good look like at Amazon? If we had this same challenge you did, which we probably did at some point, how would we fix it and why? So once we kind of have these documents written up, including some functional design work, personas and user stories, maybe some high-level technical architectures, we begin to do some business benefits analysis. So we recognize that nobody's ever going to move forward with a project without understanding what an ROI could be, what the payback period might be. And so we'll take a look really with the finance team generally, or FinOps, and do a deep dive into what could be the payback, what's the potential savings or opportunity cost. If we're able to increase throughput or drive some additional revenue through production, increase production capacity, then we'll certainly take a look at that. And once we really have an understanding of the potential savings, there's a lot of other metrics or important things that we may need to look at that could influence what gets done first. So on this particular scatter plot, we're looking at increase in throughput on the x-axis versus ease of implementation on the y-axis, and where the size of the bubble reflects potential savings. And many times there can be many different versions of this plot introduced where it might be labor reduction versus quality improvement, or on time and full delivery KPIs versus landed cost. So there's a number of different ways that we may take a look at all of these use cases and understand really how do we prioritize them. Once we have that done, and for me the most powerful part of the assessment, before we move on to Unnati and Corey for the delivery pieces and the techie piece of this, But one of the most powerful pieces for me is the building of this transformation roadmap. This kind of makes this an approachable, easy to understand, viable delivery pipeline or transformation roadmap for the customer. This particular example, it's the exact same use cases that I showed you earlier, built into a 3-year plan, a phased approach, but now we understand why do we start with certain things, when do we roll into certain areas of the project, what unlocks or enables other areas, and so it kind of gets built into a plan that we support. Just a little bit about business benefits. This is not an exhaustive list. Every customer is very different in our space. We could be talking about a 1 million square foot warehouse or a 100,000 square foot warehouse. There could be 900 people on the floor in a shift or 9 people on the floor in a shift. And so the types of business benefits and those quantitative outcomes vary greatly. But what you're looking at are some of the types of improvements that we've experienced deploying these technologies ourselves at Amazon.com. I like to say kind of we are our own best reference because we're really just harvesting this program from our own warehouses, obviously, but also blended with a number of customer outcomes as well. So to keep you all engaged a little bit through this silent session, since you can't ask me questions, at least not now, a couple of maybe proactive FAQs. So can you work with my existing ERP or WMS? Something we get asked a lot, absolutely. We are agnostic to the applications landscape, as I mentioned. We have customers running WMSs on competing clouds, et cetera. It's not important. The data might be. Do I need to buy a license? This is not a monolithic business application. This is a technical architectures built on AWS, a series of them. I mentioned 15 to 20 kind of pre-built technical architectures. And so it's all based on AWS platform services consumption pricing, just like any other solution would be. And do you need to do the assessment? No, but we find our customers probably get the best value through completing that assessment process and being able to move through that whole map more efficiently. And quick trivia, what is the record for the fastest time from click to delivery? So that means from the time someone clicked buy on their laptop to the time that package showed up on the door. Can you raise your hand if you think it's A? Got a couple? B? Or C? Got some votes? All right, it is A, 15 minutes, 29 seconds. The package was cocoa and cookies, for those that might be interested, and that was in Arlington, Texas, around Christmas time last year. So I think Amazon's gonna be very interested in beating that time this year. To somebody, I'm sure they'll make it happen. Finally, I'm gonna close here and turn to Unnati, but I'll leave you with a question really quick. How is it technically and tactically that we've been able to stand up arguably the world's largest supply chain and fulfillment network in well under 20 years at this speed and scale? And we'll get into the design and simulation piece of things. There's a 5-phase approach here. Unnati is going to cover survey and model, representing Amazon.com. And then Corey's going to do design, simulate, and analyze. We've got a couple amazing partners that we want to call out with Spinnaker SCA, a Publicis company, and Big Bear AI, where we leverage some of their technologies and a simulation engine to do that. So, Unnati.
Thank you.
Yeah.
Thank you, Eldon. So, hello again. I'm Unnati Joshi, Senior Manager with Engineering Services within Amazon. So, I've been with Amazon for almost 8 years. And my Amazon journey has been starting with change management in the warehouse industry, moving into leading a design integration team. And now I lead a new team that is very focused on reality capture as well as building information modeling and digital twin development. So as I talk about what we are doing right now, we are also using the very same technologies and methodologies in this way of offering. So with that, talking about a little bit about where do we fit in? What does engineering services do, or what does Amazon.com do? So I do have a question for all of you. Have you, and if raise your hands, have you ever wondered who actually executes the supply chain for Amazon.com? Yeah, that's the question, right? Like, who does it? And I think that answer is squarely global, the engineering services, along with their partners. So it's a very big team that is doing the design, planning, and execution for the warehouses. To continuously make sure that we are making sure that our buildings are efficient, we are always investing back into the infrastructure. One of the things that we do is survey and modeling. So when you have brownfield sites, you need to start somewhere. You need to know what the existing case is or your present warehouse facility looks like. Once you have that information, then you can start with future state design and simulation and so on and so forth. And survey modeling goes back to kind of getting the physical right, which Eldon kind of mentioned. So now I'm going to go back and touch base with Patricia. Patricia has just signed up. She finished the WAO assessment. She is clearly excited to move along for the design and simulation stage. And the design simulation stage actually has 3 critical steps, if you will. So the first step is getting your existing physical right. That is your survey and modeling. The next is, of course, design and simulation that Corey will be talking about. So how do we do survey and modeling? That is kind of what I'm going to be talking to you about in the next few slides and the presentation. So first thing is, why us? Why Amazon.com? You can go to pretty much anybody for a survey and modeling system. It's really quite simple. We provide a service that is affordable, fast, and accurate. The methodologies we use, the technologies we use provide us accuracy up to 2 centimeters plus or minus, give or take. So that's phenomenal. When you were talking about, warehouse that are 500,000 square feet or more with highly complex systems, that level of accuracy may or may not be required. So what the customer gets is a choice, whether they want to be that accurate or not. But once you get that information, the building information, it's the data interoperability that is really critical for future state. Because we are now talking about getting a base model, but we are talking about Gen AI, we are talking about connectivity to other systems. You need to have a data set that can now be integrated with tools like your IoT devices, AR, VR tools, computer vision, that can further lead into digital twin development, that can finally lead into analysis or analytics, where the end user is not really looking for having to dig around, extremely technical documentation. They just have what they need in a graph or in a quick site dashboard. So that is kind of why the survey and modeling and the digitalization of that is really critical and important. Now, when we do the WAO assessment, that's the first stage that we go to the site. What Patricia is going to see is, she's going to see either Corey or Eldon walking the site with a 360 camera or a GoPro kind of a system. What this is doing is leveraging a technology called photogrammetry or a methodology called photogrammetry. What photogrammetry does is, it just captures a video, but it is not able to give you accurate measurement. So you can see real time what the facility might look like or what the environment will look like. And this is enough for us to make the initial predictions or initial analysis of what we need to do to provide a good proposal. Once once Patricia is in the design and simulation model, now this is where we really start looking at more solutions and technologies that give us accurate measurements that can be used for design, for future state, that can be used for simulation, that can also be used for digital twin development and a whole bunch of other things. So scan to BIM, as it is called in the industry, is a 4-step process. What you have is scanning. We use very special equipment for scanning. Then the next is processing the data, and I'll get back to that there. The next is the third most, I would say probably the most important, is the asset tagging, and we'll talk about that a little bit. I would request all of you to keep that in mind. And then the final stage, of course, is the modeling, which is, ultimately what the customer wants. And the model is also a handoff point for our team over to Patricia's team, as well as Spinnaker and Big Bear AI for future state development. Now, what you see here is a machine. This is a LiDAR machine, LiDAR scanner, which is LiDAR stands for light detection ranging. And this is kind of a 360 camera. This is one of the scanners that we use. There's another one that is called Navis VLX3. They have similar use cases, and it depends on when we want to use what. But essentially what you get is the scanner is sending a light, a light signal out. It's hitting an object and it's coming back. And when you get the object back, it's coming to you in a form of a point. Now, it's critical because this point has x, y, and z coordinates. When you have x, y, and z coordinates, it means that you can start mapping in real time, geographically, all the elements of a building. So as you're walking and scanning, you can start seeing kind of a point cloud, as it is called, because many of these points are called clouds, and you see this point cloud happening.
I like that.
And this video is like clearly showing you how the aggregation of points happen, and you can start identifying every single space within that. The wonderful thing with this is you can do a lot. You can do tagging. You can tag that chair and say it's a lounge chair, it has yellow cushions, or you can even tag light fixtures or cameras or whatever else that you want. Now, I talked about tagging, and this is important. So from the point cloud, we have now moved into actually modeling the site. And as we are modeling, as we are drawing it out, we are modeling every single element that you see out there. So it could be chairs, it could be light fixtures, it could be your security cameras, it could be guardrail, pallet jacks, all of that. Depending on what the customer wants, we can go as far as adding data into every one of these elements. So I like to think about it as building elements, material handling elements, that would be your conveyance, racking, as well as your 5S or your associate facing elements. So the pallet jack out here, obviously I can't share the details, but we've given it a fictitious name saying it's an Acme power jack. So I start embedding data into the model. And why do I do that? Not because I can, but because I can extract data from there, right? So if I can add data into it, I can take back or take out data, which is helpful for digital twin development and helpful for analytics. We'll come to that in a little bit. But that is kind of what we do and talk about when we talk about asset tagging. Now, this is kind of just a short video, which is actually walking you through how we progress from a point cloud to actual development of the model. So we've kind of overlaid an old drawing that we had, which you can, by the way. You can compare the old drawing to your point cloud. So you have your point cloud, and then we start drawing out with bounding boxes all the other elements out here. So we can add placeholder data, we can connect it to data, which is what Eldon talked about as the systems connections. So this is kind of where we start getting those foundations in place so that you have the potential for a living, breathing model that can be used over and over again. From here, you now have the final state of a building model. What you're seeing here is a fly through of what we've built and what Patricia is going to get at the end of the day. Excuse me. She is going to get a full model that has all the elements modeled, and in the hidden layer below, it also has information that is tagged. So you're going to get something that shows you AC ducts, the structure, lighting, the whole building that can be data enabled. And this is critical because this now is not only the handoff to Patricia and her team, but this is also the handoff point for design and simulation. So now, how do we hand this off? It's a massive file, right? It can't be easy. But this is critical, and this is where data interoperability is really very critical for us. What we are able to do is, with one single data set or building information model set, we are able to provide multiple file formats. And this can be used all the way from capacity teams who require to understand what volume or what capacity is required in the fulfillment center, all the way to predictive digital twin analysis and development. And this can also be used by operations, maintenance, end-of-life management, design teams, engineering teams. You can continue to have multiple use cases for this. So then from here, what next? We go to the almost last section, which is FAQs. There may be some questions that you'll probably have some questions. Number one is, what is the digital model used for? Well, like I mentioned, it has many uses, and what we've seen is we've had many customers within the same group who are looking for different information for the same building. So you could be doing noise studies, you could be a team that is looking at safety, it could be a team that is looking at maintenance of facilities, or just heat sensing, humidity control. These are just some of the use cases we've seen, but then it's upon the customer, it depends on the customer. Whatever you want to use it for, you are able to use it for. The second question is, can you use the digital model long term? Well, yes, short answer is yes. However, the caveat is, if you see a lot of change in your facility, especially infrastructure change, it's recommended that you at least have some sort of mechanism to update the models that you have, or you get some professional team to do it for you. So long as you are not making big changes into your model, you can absolutely continue to use it as many times as you want, and it can be used by multiple teams as well. Last but not the least, what is a digital twin? You may have heard me talk about digital twin a lot. In short, a virtual replica of any object is a digital twin. But we go beyond that. Now, a digital twin is data enabled, so you can add in information to actually replicate real life, whatever those situations might be. Today, we have about five stages of digital twin. We provide a digital twin that is at level 2, but we are also in the process, if the customer so desires, to move into 0.25 or 275, if you will, which is a descriptive twin, which is where you start connecting the model into IoT devices or sensors. So you could connect the model back into computer vision, AR, or just sensors that are looking for fallen objects on your conveyor belt, or looking at heat sensing equipment, whatever that is. But that's kind of what the digital twin is. Last but not the least, this is a really good one. How many miles of conveyor are there in an average fulfillment center? So raise your hands for number one, 10.7 miles. Oh, well, we have one person. 13.5 miles, much few more. And then last but not the least, 18.4. Oh, quite a few of them. All right, well, the actual answer is 13.5 miles is an average length of the conveyors. So I'm not sure how many total miles there are. I'm sure there are more than that. So before I leave you and hand off to Corey, I'm going to leave you with a teaser. This is a digital twin that we built in AWS IoT Twin Maker. The fantastic thing about this is, as you can see on the left-hand side, we have assets. You see casework, ducts, structural, all these are assets that have been tagged. Now we have the potential to tag them and start putting numbers. And what you're seeing here on the right is that we are kind of playing around with sensor data and turning on and turning off certain conveyors for whatever that might be. Now, we can have specific reasons or specific instances of what we need to do with the conveyance. So if we want to have an instance where we have sensors that's looking only for fallen objects or only tracking stoppage, that is, it'll flag and it'll highlight in our reporting saying, okay, here you have, conveyor A, it's stopped. This is the sensor that is tripping it. So you can go in and have a look at that. So what does it do? It helps the facility managers actually be more reactive, like react quickly to the stoppage and get things moving faster as well. This can also be used for things like computer vision, and that is something that Corey will be talking about. But at this stage, in conclusion, we have handed off to the customer a full model with all the different 10, 15 different file formats. We have handed off to our partners, Spinnaker and Big Bear AI, a model that they can use as well for future state design. And with that, Corey, over to you.
Thank you, Unnati. So welcome again. My name is Corey Gines, and I've been in and around warehousing, manufacturing, and operations for 25 plus years. I began my career on the Amazon.com side, running one of our largest fulfillment centers here in North America. And as we all know, everything within the AWS and the Amazon supply chain end-to-end is powered by AWS solutions. I want to start today by asking you to ponder a question for your operations team. And ask yourself if your team is being proactive or reactive in your daily operations. Do you have the metrics to visually measure opportunities in real time? Do you have that visibility layer? We'll come back to that. As with every workload and solution within AWS, it begins around our 6 pillars of a well-architected framework, and design and simulation is no exception. I'll quickly walk you through those pillars, but the operational excellence pillar really focuses on running and monitoring systems. The security pillar, which is our top priority, that pillar focuses on information and systems. The reliability pillar focuses on workloads performing their intended IT functions. The cost optimization pillar really focuses on avoiding unnecessary cost. And lastly, the sustainability pillar really focuses on minimizing environmental impacts. I'll talk a little bit more about the security aspect, but as you saw in some of Unnati's videos and some of the videos coming up, we really strive for customer PII information to protect that, and that's personal identification information, and you'll see some aspects of that in some of the videos coming up. So as we check back in with our customer, Patricia, again, I'm going to walk you through the delivery portion of design and simulation. So we know from Eldon's WAYO assessment that there was a plethora of outcomes during that assessment and the narratives that were written there. And one of the main strategic themes was design and simulation. And this particular customer chose that because they're after the objective of increasing their throughput, increasing their density, while maintaining their existing footprint. Unnati then walked us through the design aspect of the survey, where we're capturing some of the open space design, so we can use that later on, which what we'll see coming up here. So now our customer has completed that. They've settled on design and simulation as they go forward opportunity, but they need to know how to solve these everyday problems, such as increased density. And as with most things, it starts with the data to make it a data-driven decision. So when we talk about the design phase, first and foremost, we want to understand what the customer's objective is. And again, in this case, this customer wants to increase their throughput and capacity while maintaining some of their current infrastructure and not move an existing footprint within the 4 walls. So once we understand that, we take a look at educating the customer on design and what types of innovation are out there today. And when you hear the word innovation, you would gravitate towards some of the aspects of the video that Eldon showed, and you'd probably be right. Most innovation, when customers hear that word, they will gravitate towards the robotics, They'll gravitate towards AGVs and other goods to person types of mechanism. But the design phase is much more than that. It's also about looking at the existing footprint, understanding if the footprint has any constraints or if any natures need to be moved, and also considering any future safety considerations. Also looking at the current and future state SKU profiles and ensuring the maximum flexibility. And this is the same philosophy that Amazon follows as we build out our network. The design phase also takes in consideration any customer constraints. Constraints around budget, constraints around looking for a specific payback period, constraints around any safety concerns or systematic constraints. Does the underlying architecture support the future state that we're trying to design to achieve that objective of additional throughput and maximum capacity? And we will typically gravitate towards the innovation that we see in the marketplace today. We really refer to this as LFA, which is learning from Amazon. We do that through a variety of aspects. We look at computer vision, we look at AGVs or ASRSs, and any mechanisms that will allow goods to person autonomously. So now that we've educated our customer on the design and what types of innovation are out there in the marketplace today, now we're going to move on to the next phase, which is simulation. And why does Amazon do this? And why is this a successful footprint for Amazon? Because we want to simulate the objectives of the future state at achieving those KPIs that are achieving the throughput that's necessary. But we want to do that through simulation. Before we go out and make any large capital expenditures in some of the robotics and mechanisms that we referred to earlier, we want to simulate that and make sure that we can achieve those future KPIs. And simulation is a great way to do that. The next couple phases I'm going to talk through is really, we're proud to talk through some of our partner relationships and some of the partners that we leverage throughout the journey of design and simulation. So first, when we talk about simulation, it's really the digital twin process, and we know that there are multiple levels of digital twin in the marketplace today, and a two-dimensional AutoCAD drawing is no exception. So we take that two-dimensional drawing and we transform that visually into a three-dimensional model using leveraging a customer called BigBear.ai, and they have a solution called PRO205. PRO205 allows you to simulate everyday operational functions, such as, do I have enough warehouse workers to keep up with the inbound demand? And if not, let's go in and make a configuration. Let's assign more work. And let's alleviate that bottleneck in the operations. The simulation phase is much more than that, right? It's the way to take your traditional current state and really understand how we transform that into the future state while achieving the business objectives that we're after. In this example, it's a goods-to-person solution. Now, the PRO205 solution is fantastic to see mechanisms moving throughout the warehouse, to understand any safety concerns or observations that might hinder that meeting that customer objective. But the solution is also important from a data-driven decision standpoint. It's great that we can see and visualize what the future state looks like, but it's also important to measure that success. So we start with the current baseline. What are our current metrics? Then we hydrate the solution with the customer's information, so your SKU matrix that I was referring to earlier, and we'll run a series of simulations to see the after effect. And did we in fact achieve that success? And that's how we can determine what the next step is here. And the next step, after we've designed, after we simulate, we've achieved the objectives that we're after, Now it's time to operationalize that. So let's go put into reality those mechanisms that we just called out, those various types of innovation that call out the aspects that we were after. How do we do that? As with any solution, you're always going to start with change management, right? And we like to refer to this as the 5 lenses, which are people, process, technology, policies, and metrics, and ask ourselves a series of questions. With people, is the necessary commitment clearly in place? Is everyone operating off the same page and understanding what the future state objectives are? Process, are the current processes aligned to the future state business objectives? If not, let's go in and look at those standard operating procedures. Technology, do we have the underlying systems architecture to support that future innovation with interfaces and things of that nature? The policies and our standard operating procedures, do our policies align with the promise to our people and our customers? And lastly, the metrics. What are our target KPIs? How do we visualize that? And are we monitoring those in real time? So another partner that we leverage in this journey is Spinnaker SCA. And we're very proud to talk through this as this is the way we begin to operationalize that. So how do we take all that data and begin to make operational decisions around bottlenecks within the workplace and address that proactively? And we really do that through what we like to call the Warehouse 4.0 or Warehouse of the Future. And how do we operationalize that? Wayo is the perfect vehicle to do that, and Eldon talked through that. But we'll leverage the current capabilities around capacity planning, lean material flow analysis, all while considering your current solutions around WMS or TMS or ERP that you're leveraging today. All to give you that competitive advantage in your vertical to allow you to work smarter, not harder, and a seamless omni-channel. And again, as I mentioned, it all begins with the data to make that a data-driven decision before you go out and operationalize that. So understanding what the objectives are, understanding those metrics, and do we have the delta in place to achieve that? And really that's taking that business case from paper to platform, using data-driven decision to achieve our future state warehouse. So those are kind of the last 3 phases of design and simulation, but why stop there? So I'm going to talk just a few minutes as we wrap up about some of the trends that we're seeing our customers go above and beyond, and we refer to that as operationalizing or optimizing. So once workloads such as solutions like design and simulation are in place, how do we go above and beyond? How do we optimize that? Well, with the time remaining, I'm just going to cover off on a few of those. One of those examples is data synchronization. So taking all of your data, understanding all those current data sources, and hydrating a data lake, and reporting off of that so you can understand insights and trends with your data. And that's really a transformational journey of that data. As I just mentioned, it starts with that base layer, hydrating a data lake, identifying those data sources, ingesting that data, and then use the reporting to look at those insights. But why stop there with reporting? Let's drill down on those insights and let's look for bottlenecks. Maybe forecasting, maybe bottlenecks within the operation or workloads that are currently in place. And then let's begin to leverage AI and ML. So how can we look at those insights and draw conclusions about what will happen if we don't take action on these insights? And what are the root causes, right? It could be things with forecasting. It could be bottlenecks in your current capacity. Then lastly, in the transformational journey for data synchronization is the orchestration of automation. So this is where Amazon.com is in its journey today. So we're looking at those insights, but we're taking action, right? We're taking action proactively to push data for routine decision making. One more way to optimize, example trend in the marketplace, is leveraging AI and ML or computer vision. And this can be in a variety of capacities around inventory control, your inbound and outbound, and also with safety and addressing any maintenance concerns. So in this example, you've seen another example of identification of PII with personal identification information. And in this customer example, there's a lot of masking going on, but this is just to give you an example of what computer vision can do for you. So why leverage an existing technology such as computer vision? Let's take some of that decision process away from employees, some of the routine opportunities, and let's have our employees focused on value-added work. And in this example, you're going to see an employee moving through the warehouse, and they're getting their identification. The information that's leveraging with smart glasses is really what is that minimal information you need to execute the work order. As you can see in this example, you've got descriptions and so on. We also leverage AI and ML, leveraging IP cameras. Why do we do this? Because we want to measure and understand the model configuration of the SKU matrix, because we're primarily focused on the accuracy of the pick and increasing the accuracy that we're after. So that's just one example of how computer vision goes above and beyond for optimization. Okay, another example is analytics and visibility, and that digital twin layer that we referred to earlier. And this is a way to understand what are our alerts, what are our notifications, are you monitoring the right KPIs, and are you being proactive with your leadership on the floor? And lastly, I want to talk about Gen AI and some of the use cases in warehousing for optimization above and beyond. And Gen AI, in this example, really refers to some of the manual paperwork processes that might be prone to human errors for recording or writing, things of that nature. And let's figure out what's the use case for document digitization and leveraging Gen AI. And that journey of Gen AI, well, we all know that customers have information scattered in Excel, PowerPoint, things of that nature. And we use Gen AI models such as foundation models to extract and structure that data. We then use a different set of foundation models, such as large language models and RAG, retrieval augmented generation, to optimize the output of those large language models. And really, lastly, to develop some of these examples such as document classification and chatbot. So it's time for some trivia now that we've seen the journey of our customer. What's the difference between design simulation and operational simulation? Well, operational simulation is what we showed with the partner of Spinnaker, where we're understanding the capacity planning, what's the current footprint, and what are the current SKU profiles. And the design simulation is in fact simulating the future state. So there's an operational and future state aspect of that. Another frequently asked question is, are you affiliated with any specific robotics and automation? And the answer is no. We're agnostic, right? We're well aware of what's in the marketplace today. We're leading that in our logistics distribution network today, and we want to share that with our customer base. The third frequently asked question is, why is data synchronization foundational for WAO intelligence? Well, as we mentioned, it starts with the data. Do I have the right data? Is it in the right repository? Is it accessible? Can I report out on it? Can I leverage things such as AI and ML to make some of those insights and take some proactive decisions? Okay, so lastly, for a trivia question by show of raising hands, approximately how many total square feet does Amazon operate globally across FCs, sort center, delivery stations, and hubs? Raise your hand if you think it's A, 188 million. Raise your hand if you think it's B, 435 million. Raise your hand if you think it's C, 624 million. Yep, the answer is C. Actually, answer A is 188 million. That's in EMEA. 435 is in the Americas, which total the 624 million. So now I'm going to ask my colleagues to join me back up on stage. Eldon, I'll turn it over to you.
Great, thanks, Corey. Thanks, everybody. If you would like to, well, actually, before we learn more, just to wrap up on finally the last time, we'll step back in with Patricia. So, as our example WAO customer, we've taken Patricia from the assessment, how do I even approach bringing up my existing warehouse network, all the way through this journey, modeled existing facilities, designed, redesigned new facilities, new layout, new material flow, gone through the simulation process to justify that CapEx, implemented and operationalized that solution, and then Corey showed you some of the optimization steps. And at this point, we would hope to scale those solutions out through a larger number of facilities across that network. If you'd like to learn more or talk to us a little bit, we'll be here for just a minute after the presentation. We'll be headed over to the AWS Village in the Expo in the Venetian. And we'll be there this afternoon from 1 to 4. I think the Spinnaker team will be there as well. But if you'd like to talk to us or ask any further questions, we'll be there. It is, forget about finding booth 38. I don't think it exists, but zone 4, right in the middle of the big Venetian Expo floor. There's a professional services kiosk, so you'll see us there tomorrow. And there is a little bit of a mistake here I got to call out. Tomorrow we'll be at the Publicis Sapient booth. So Spinnaker is a Publicis company. It is not the Caesars Forum Expo. It is the Venetian Expo. Tomorrow afternoon, we're 2 to 5 today, 1 to 4 tomorrow, booth 1823. If you have an AWS account manager, I mentioned going on a fulfillment center tour, doing a learning from Amazon session, reach out. We'd also be happy to try to take some information at our booths as well. So thank you all so much. Appreciate it.
Thank you.
Yep. Oh, and last thing, very importantly, please, please, please do a session survey for us. All right, if you'd like, supply chain content and reInvent is hard to come by. So give us a good survey and we'll get some more. Thank you.